do that? This one too.
Hold on to it because I'm going to have one person. So, bring your articles to your seat. I'll take the articles and the answer sheets in just a second. We're going to add one thing together. We're going to add one thing together. That person who has the original sheet where you're putting your answers for these questions, they can add a couple more details, but just note that needs to have both of your names or all three of your names on it for me, okay? Got it? Cool? Okay. So I think that most of us, I heard the good conversations that you guys kind of know where we're going, so I'm not going to spend very long on reviewing these because you guys have a web quest today that's going to give you some more information on heat, temperature, and the calculations go along with them. But the questions that I did want to do were the ones right here in red. First of all, let's talk about number 3. All particles of substance have the same kinetic energy. True or false? False, right? That is not all the time true. Yes, all the particles at one temperature have the same something kinetic energy, but it's not exactly the same kinetic energy, the same average kinetic energy. And there was a graph on the back of the Does Cold Exist article that kind of showed this bell curve distribution curve. And so that's just saying they all can't have exactly the same, because right, I heard a couple people going, when you collide, sometimes you change your speed, you change your energy. So, but overall average is the related to the temperature. So that number 3 feeds into question 4. What was the definition of temperature? You guys have your reading guide in front of you. What's the definition of temperature, Rishi?
The measure of heat.
It's not really the measure of heat. It could be the measure of heat transfer. It could be a measurement of something else. I'm going to stick with a more actually basic definition. Caroline?
Temperature is the measure of average heat or thermal energy of molecules and substances.
Okay, so I'm looking for average energy. So temperature is something that we can actually measure. We have a thermometer we can measure that with. What can we measure heat with? Do we have a device that measures heat? No. Does anybody know what heat's units would be?
Joules.
Joules, right? So heat is measured in joules. And joules is a form of energy. But we don't have a little device that you stick into a cup and go, let me measure the heat, right? Because there's nothing that measures joules per se. We always have to calculate heat. Heat's not really something we can hold. Heat is something we can feel, but it's always a change in energy. So if you're holding an ice cream, a bucket of ice cream because you're just not having a good day, and you're at home, and you're on the couch, and you got a gallon of ice cream in front of you, what do you feel on your hands? Don't you say cold. You feel the lack of heat because what's happening? So the ice cream bucket's sucking the heat out of your hands and it's giving it to itself because it is colder or lesser in energy. It's taking the hot energy from your hands and sucking it in, right? The energy is transferring from a hot object to a cold object. And so I can't really measure the heat, but I can definitely feel the change in heat. I can feel the change in energy. Yeah. Mm-hmm. Very
I noticed like the ice cream.
So does it stick to the pillow?
Yeah, and so I have to like pull it off.
Right. So if you pull off is because when the ice starts to melt, the ice, so water is very different, right? Water expands when it freezes, and so it shrinks or contracts when it starts to melt, and so the shrinking is like kind of like almost a vacuum. It sucks the fluid and it sticks to it. That's why it's like a sheet. That's just because water's weird. But water's good. You need water daily. Okay, make sure you know that. Okay, so back here, definition is definitely as an average of the kinetic energy of the sample, the entire sample. Can you guys demonstrate for me the 3 types of motion? So vibration? Hold on. Vibration what?
Translation, and rotation.
All right, so that's basically what particles can do. They can't really do anything else. And then the last one I'm going to do is the one at the very bottom that you had. Most of you guys probably didn't get to number 9, but let's go ahead and sketch this now. Sketch this on your article, sketch this on the paper, sketch this on your reading guide. I don't care where you sketch it, but we're going to sketch this together right now. So label a heat curve. Who remembers drawing a heat curve? What's a heat curve look like? Say again? Stairs, not a curve, right? not a curve. Okay, so draw your curve. And I'm just going to be really brief with this because I know that you're going to see this again later with me. So what's the y-axis here? Temperature. And the x-axis? Time. It could also be called heat added. There's another way to say that. And so temperature versus time, or temperature versus heat added. Noticing that we're identifying temperature and heat as two different things, so they cannot be the same thing, so we should not use them interchangeably. So if I'm going from a solid to a liquid to a gas, how does my curve look? How does it start? Flat or slant? Slant first, so this is our solid. And then what happens? But what's happening here? Phase change called melting. Okay, so this is solid and then it's melting. And then we go to liquid because it's now all the way melted. And then what happens to it? Evaporates, or vaporization is another way to say that. Melt, vaporization, and then we're all the way over here to gas phase. And so you can definitely see that the temperature correlates to the kinetic energy differences between these states of matter. Which state of matter has the most kinetic energy again? Gas. And so as the temperature is increasing over here, temperature is increasing, you can also say kinetic energy is increasing, and you can see that's occurring as the states of matter are changing as well. I will say there's one more term that you should know here. The heats of vaporization, or the heats of the energies that are required to cause something to melt or cause something to evaporate, we call those delta H's. And we have talked about delta H a little bit before. We're going to get into more detail now. But delta H of fusion, delta H fusion is the energy it takes to melt something. So delta H, that has a name. Starts with E. Enthalpy, good job. Okay, so enthalpy is what she said. Enthalpy of fusion means the energy it takes to melt a substance, or that particular substance. And then this one's called delta H vap, delta H vaporization, and that's the energy it takes to vaporize something, right? It is a specific quantity, and we'll kind of get into that later. But in terms of a heat curve, we should just remember it's not a curve. All right, so we're going to switch modes here. These people here, can you guys grab your laptop? And then want to kind of do a phase here. So in terms of finishing introducing ourselves to Thermo for now, I'll do some calculations towards the end of class. I did have a couple people who still didn't take the benchmark because that weird thing happened yesterday. And I realized what happened. You said log into Google. That was it. So log into Google. So I'm gonna split our time right now. So otherwise, you guys are working at WebQuest for now. At the end of class, last 15 minutes or so, I'll do some calculations with you. So the WebQuest is under my Unit 6 documents. Next people, go get your laptop, please. Unit 6 documents. And it looks like this when you pull it up. Next group, please go grab your laptops. Oh, thank you. Trying to make sure I got all those. If I did not grab your index card, please bring it to me. It is in Unit 6, yes. Thank you.
Excuse me, yesterday, I think I might have like a pouch with just a bunch of
Around it, yeah. So when you go to my website, thanks for the box. Under Unit 6 documents, it says Thermo Chem WebQuest Final.pdf. It's very specific. When you go there, you'll see the WebQuest with the questions. Be as brief as you can on those questions. You do not need to write complete sentences. This is really kind of making sure we know what we're talking about when we stop talking about heat, temperature, kinetic energy, and so forth. So you can work with a friend if you would like to talk to them about chemistry, but if you get off task, you're going back individual, okay? So it might be easier to have one person have the website open, one person have questions, but everyone's writing their questions down, right? So even if you work with somebody, it's there for conversation, not for a combined paper. So on the very bottom, you'll see it has I'll scroll through here first. The next question talks about specific heat calculations, which we'll do toward the end of class. And then there's the equation for it. There's another curve for talking about energy of heating water and then melting ice. This is just a couple of, this has like a little video you're listening to, and it reminds you of exo and endo, some of the things that you'll notice that you actually know a good bit about. The very last part has you look at 15 things that you could do to increase the energy efficiency of your home. So when it says for homework, finish WebQuest, it's probably that. How are you thinking, looking around your home, where could you have some sort of improvement in your energy usage? Okay? You guys good? If you're a WebQuest person, I'm gonna put the link on the board, and I'm gonna have you guys sit elsewhere, kind of spread out. But give me 1 second to put the link up. I mean, yeah, what did I just say? Whatever I said, I meant benchmark. WebQuest. If you're everybody's a WebQuest person. If you guys need to spread out to go to lab stations, that's fine.